gives me a CSV or some version of an Excel file. So if I open this up, and I'll do it this way, as you can see, I have data that looks like this. I have date, I have open, high, low, close, adjusted close, and volume. Now the difference between close and adjusted close is a lot of times you will see the close and adjusted close to be the same, but not always. As you can see here, they were not the same for that particular time. What happens is, after the markets close, there can be corrections related to the specific trades that were done, and the market adjusts itself for the volume as well as the prices that happened during that time. What we're going to be using is the adjusted close, none of this. By the way, for other types of research, you can use these information, and we do in academia, we really do use this stuff. But for this project, all I'm interested in is the adjusted close. So I'm going to delete all this, and I will end up with adjusted close. I also don't need volume for this particular project, although volume is great information, but not for this project. All right? Okay, so I have my adjusted close and I have my dates. Before I go any further with this Excel thing, there is a significant chance that whenever you click this data tab up here, you're not going to see a data analysis module. Now I have it here because I uploaded it, but most likely you will not have this here. If you don't, it's very simple to upload it here. What you do is you would go to File, and you would go to Options right here, and then there's something called add-ins right here. If you click add-ins, it will give you a variety of add-ins that you can choose from. So what I'm looking for is right here, it says Analysis Toolpak. That's the one that I want. I will click OK, and it should give you the data analysis module right here. If it doesn't, if your version of Excel is slightly different possibly than mine, just Google how to add in data analysis add-in to your Excel from Google, and that should be a straightforward process for you. I'm assuming that you will get this done before you start the project. All right, so now I can see the data analysis right here. The thing is, this is not all the information that I'm going to use. Just so that I can keep track of all the data that I have, this adjusted close section, I will call it ExxonMobil or XOM or XOMR. Well, no, I'll call it XOM for now. All right, what you're going to have to do right here is calculate the returns for those. Don't forget, these are prices, daily prices. If you remember your capital asset pricing model, 3-factor model, 4-factor model, all of them have at the very beginning expected rate of return, right? So the left side of all of those models, all of those equations, the left side is expected rate of return. Not prices, but returns. How do we calculate return? New minus old divided by old. We talked about that before in class. So what I need to do in this particular case is like for example, this one is what? January 4th, 2010. The next day is January 5th, right? So it needs to be new minus old divided by old. However, this will leave me with an empty slot right here. So that what I want to do is I want to sort this from newest date to oldest date, because it starts from 2010 here and it goes all the way down to 2016. I don't want that. I want it to start from 2016 or the newest date according to this data set. So what I can do is I can basically highlight all of this, and if you're wondering how I did that, I basically said Control Shift and down arrow, and that highlighted the whole thing for me. And what I want to do is I want to go to data and I want to sort, And it says my data set, my data has headers. I will say it does not because I started from the date right here, and I want to sort by column A, and I want it to be newest to oldest, and there we go. Now I have from 2016 down to 2010. So I'm going to now calculate ExxonMobil's return. How am I going to do that? Well, again, as I mentioned before, it's new minus old divided by old. So I'll call this ExxonMobil return. So the return for this day equals this day's price minus the day before's price, or new minus old, and then I need to put this in parentheses for mathematical accuracy, divided by old. Which one is old? The day before. So it's this guy. New minus old divided by old. Whenever I press enter, as you can see, it shows me that there was a negative return, negative 0.001 return. Right? What I'll do is I will do the exact same calculation for every single thing here. So I go to the corner and I double click that, and it does the calculation for everything down here. Okay? As you can see, the very bottom number is says I can't divide by 0 because there's not a number right before that. That's normal. You will leave it as that. That's not going to bother you for this regression because we're going to take the numbers up to here. All right. Okay. So now I have all these numbers, all these returns that I calculated, but this is not it. I need specifically the 3 factors and 4 factors in this data set as well, so I can do all my calculations using the same data set. For that, you're going to go to your email for your web browser again, and what you will do is you will go to a website called kennethfrench.com. Okay? If you go to kennethfrench.com, you will, but by the way, remember the FAMA French? This is that French. Data library, and this will give you the data that they've calculated already for you. Now, if you are in academics, we calculate this from scratch ourselves all the time. You don't have to do that. These guys are pretty good at calculating their own data that you can use to evaluate the stock of your choice. So that's what you're going to be using here. See, it says all these datas are downloadable files. Here you see FAMA French 3 factors. You see FAMA French 3 factors, that is weekly. You see FAMA French 3 factors, that's daily. Clearly this one is monthly. You have something called FAMA French 5 factors. We didn't teach that in this class, but there's something that exists that's called FAMA French 5 factors. If you're interested in that and you want to run it that way, you can use this data. For our purposes, we're going to go and, as I mentioned before, we always use daily data. FAMA French 3 factors daily data. I click the CSV because I need it to be in some form of an Excel format. And whenever I press on this, if you have hopefully some form of a zip file opener or WinZip or something like that. If you don't, you know you can get a free copy or a free valuation copy. So I double click on that data, and as you can see, this is what it gives me. Let's see what that is. You might be able to recognize this data now. See, SMB, HML, RF. RF stands for risk-free. Market minus risk-free. Remember, this is them calculating market return minus risk-free return for you. So you don't have to worry about this particular one or any of this stuff for that matter for your regression analysis. So just like the ExxonMobil's daily data, I also have the daily data for the 3 factors in this case that FAMA French gave me. One thing that you will notice here is that this date column doesn't look like a date. In fact, it's just numbers. Although they're dates, the Excel doesn't recognize these as dates. So you need to fix that. How do we fix it? Just highlight it, go to data, go to text to columns, click on fixed with, next, next, and I'm defining this as date. What does it say here? To 1926-0701. So 07 is the month, 01 is the date, because I can see that the day is changing, the 07 is not. So this is year, month, day. So what I'll do is I'll say year, month, day, and I'll say finish. Boop. As you can see right now, all of this is changed to an actual date format. That is comparable to the date format that I had for my ExxonMobil's return. This is what I need. Also, one thing that you're going to realize is that, first of all, this data starts from old to new, but our ExxonMobil is the newest to oldest. So I got to change that. And again, what I do is I highlight all of this and then sort it. And my data doesn't have headers. If you highlight it all the way, including these top guys, then it has headers. If you only use the dates or the actual data, it doesn't have headers. So in our case, it doesn't have headers. And I want to sort by column A. And I want it to be newest to oldest. Well, in this case, Pharma French has data all the way up to February 28th, 2018. Well, I don't need that because my data starts at 12/30/2016. So what I'll do is I will delete this stuff and make it comparable. So I have 12/30/2016 as my start date on this guy right here. So I got to match that, so I will delete this. There we go. So my dates are matching right now. However, also I know that I gave you, for this example, that your date should start at 1/4/2010. So my other date needs to start at that as well. 1/4/2010. So where is that? 1/4/2010. So all of the guys below this I don't need. There we go. So now I have matching data sets. So what I'm going to do is I'm going to go to my Pharma French's information, highlight all of these guys, copy, and I want to paste them right here. The cool thing is that since the dates match, I don't need this date. So now I have the ExxonMobil's return, market minus risk-free load, or the market minus risk-free regression load factor, SMB factor, HML factor, and the risk-free amount. I have those now. All right, so you have all your factor loadings, and you have the return. In this light, what I need you to understand is that you need one more guy in here to have all the data you need for all of your calculations, your CAPM, your 3-factor model, your 4-factor model. And what is that guy? That's the momentum factor. As you can see here, if I go back to the Kenneth French website and scroll down, I will see right here a momentum factor. In fact, I have the momentum factor daily, just like I would have for everything else. So I click on the CSV, same thing, CSV, and then If I double click on that, as you can see, the momentum factor here, the same dates are here. You're going to have to clean the dates just like you did for the three factors. You do the exact same with the momentum, and what you do is after you clean it the way that you need to, just like the other three factors, then you plug it right here and it becomes your momentum factor. So you would have the fourth factor right here. But that's for you to figure out for your project. In this example, all I'm going to give you as an example is the three-factor model. It's your responsibility to do the capital asset pricing model, the three-factor model, and the four-factor model, including momentum, in your project. Okay, so how do I go about running this regression? Now the good thing is, since I have my returns and everything else side by side, what I'm going to do is go to my data analysis toolpak, and I will see here something called regression, or a line item called regression. If I click that OK, now it says what is your y range, what is your x range. As you might remember, in regression the left side of the equation is your y variable and everything on the right side are your x variables. If I'm doing the three-factor model, I have, in this case, how many x's? I have 1, 2, 3 factors, so 3 x's, right? X variables, or 3 independent variables. So the first thing I will do is input my y range, and my y range is right here. And what I want to do is, instead of 1763 in this case, I want to not include this last guy. So I'll make it 1762. So that's my y variable. And I can highlight all the x's together and it recognizes that automatically. So what I'll do is I'll highlight that. And then go all the way down, but again I'm going to exclude this last guy, so it's going to be 62, and I'll press enter. So my data has labels. I've given the y range as well as the x range. For this purpose, this is not a full-blown statistical analysis, and I'm not necessarily expecting you to be statistics expert. All I'm looking for in this case is, can you do the regression and calculate the coefficients for the regression? For that, I don't need to go into the details for any of these guys for this particular project. All I say is okay, and I want it in a new worksheet. So there we go. This is my regression output. Alright, so let's open this up and see how we can interpret this. So let's look at this regression now, or regression results, and see what it's trying to tell us. Okay, what I'm most interested in is these coefficients right here. These coefficients are the beta measures that are in the model. If you remember a three-factor model, what does it look like? Remember it from your lecture. Let me actually pull that up real quick, and so that I can literally show you what I'm talking about. Give me 1 second. Okay, so this was your lecture that talked about the factor models. So let's look at the three-factor model slide right here. Look, you can see that there are three factors, right? SMB, HML, this market minus risk-free rate, and just the regular risk-free rate. So the factor 1, this factor 1, factor 2, factor 3 in our case. As you can see, there's a beta SMB. What this means is it's the beta of this SMB factor. This little SMB right here is just a label. It doesn't mean anything. It's just trying to label this beta. So beta SMB, what that means is the SMB is my data, and beta for that SMB is what the regression calculated. For example, right here, as you can see, for the SMB factor, I see a coefficient of minus 0.003. What this means is the coefficient or the beta for SMB is that number right there. So that's this number right here. Okay? Same thing with HML. The coefficient you see here for HML right there is this beta right here. Okay? So regression essentially calculates the coefficients for us, or the betas for us. That's what it does. That's the sole purpose of regression, to calculate the coefficients. What is a coefficient? What that means is, how does this factor impact the return, in this case, for my stock, in our case ExxonMobil? How does the HML factor impact ExxonMobil? The answer to that question is the coefficient for HML, which is this guy right here. Okay? These are important for me. Why are they important? Because essentially what I'm going to do is calculate what the return for ExxonMobil is for a specific day that I'm going to give you. I'm going to calculate the return using all these coefficients. And what I'll see is what it's supposed to be, what the return for that day for ExxonMobil was supposed to be. Let's say ExxonMobil was supposed to give a 10% return for that day. That's what I calculate using these numbers. However, what I do is then later compare that with the actual return that ExxonMobil gave for that day from historical data. And when I compare the two, what I see is what it's supposed to be versus what it really is. And that gives me an idea of, as of that day, if the stock was overpriced or underpriced using this particular model. So let me clarify that in terms of how we calculate it. Again, all right, so let's say that I've got these coefficients for ExxonMobil, okay? What I'm going to say is, all right, let's say I gave you a date, and the date is, let's say the date is 12/30/2016. That's the date. On your assignment, I said, please evaluate the stock of ExxonMobil as of 12/30/2016. Okay? Well, how am I going to do that? Well, what I'll do is, as you can see, as of this date, all I have to do is just, so that I can remember all this. Actually, I'll copy this. You don't have to do it this way, but I'm just trying to demonstrate how you're calculating it. What I'm expecting you to do is do this calculation in your Word document. I'll explain that a little later. Okay, so what I'll do is paste here. I'll do paste special because there was a calculation in there. I want to make sure that that calculation doesn't impact what I'm about to do here. So I'll just say, just paste values in number formats. So here is what I've got. So this was the price as of that day. This was the return as of that day. This was the market minus risk-free rate for that day. This guy was the SMB. This guy was HML. And this was the risk-free rate as of that day. What I'm worried about is now I have these coefficients, I have the actual values, and what I need to do is calculate what this return is supposed to be using all this information and the coefficients. Again, the coefficients are the betas, and these guys are the actual factor loadings for those days, the HML value for that day, the SMB value for that day, right? So these are those values for that day that I'm asking you to calculate in this example. Again, this day will be different for your project, but for this example, it's that day. So how am I going to do it? Well, so let's take the coefficients as well. Let's say that these are the coefficients. Okay? And the coefficients were for the market minus risk-free, the coefficient was that number right there. For SMB, the coefficient was this guy. HML, the coefficient was right here. I'm not worried about the intercept. I've got the risk-free rate. I mean, intercept, we say, is the risk-free rate normally in this calculation, but for our purposes, I don't have to do that, because in my calculation, as you can see right here, coefficient value, there's no coefficient in front of risk-free rate. All I need to do is take the actual risk-free rate for that day. So that's what I'm going to do. So now, since I have these data, what I'm going to do is what's the return, and again, you don't have to do it this way. I'm just trying to demonstrate how the calculation is done. What the return is supposed to be as of this day. How do I calculate that? Let's look at how I calculate a model. Risk-free plus coefficient multiplied by the actual factor plus coefficient multiplied by actual factor plus coefficient multiplied by actual factor. So I'm going to be doing the same thing. So equals the risk-free rate plus the coefficient for market that I calculated right here times the actual loading right here plus coefficient of, in this case we had started with well, it doesn't matter, I'll go still continue with SMB. Coefficient for SMB multiplied by the SMB factor plus the coefficient for HML multiplied by the HML factor for that day. I forgot to put parentheses here. And that's it. So now I have the risk-free rate for that day, and I have the coefficient that the regression calculated for me right here, multiplied by the actual factor loading for that day. So if I press enter, the number I see is right here. Okay, interesting. The return is supposed to be this number right here, but the return was this number right here. So is the return, the real return for that day, the actual return for that day, lower or higher than what it's supposed to be? Well, in this case, I'm looking at it and I can see that this is a bigger negative, this is a smaller negative than this number. So this stock is paying, so you're losing money in both cases. You're supposed to be losing money in both cases. Are you losing money more? Are you losing more money in real life or less money in real life? That's the question I expect you to figure out. Look at these numbers. This number versus that number. Yes, they're both negatives. One of them is a smaller negative than the other. That means, although you're supposed to lose money on both, in reality, you're losing more or less money than you should. And once you figure that out, then you can come up with an idea of if the stock is underpriced or overpriced. Now, how to think about this? As I mentioned in your lecture before, let's look at it in numbers wise. I'm restraining myself from giving the answer for you for this particular one because I expect you to figure this out on your own. But for the purposes of teaching you how to think for stuff like this, again, let's say that the end result for a stock was supposed to be $100 price, right? I have two scenarios. The stock price is also $100. So two scenarios. The today's price is $100 in both scenarios. If you had paid $90 for that stock yesterday, you'd be making a profit, right? Going from 90 to 100. What if you paid $50 for that stock? Would you be making more return or lower return? Of course, you'd be making a higher return if you pay less money for the stock, right? Let me tell you that in reality, you were supposed to double your money. You were supposed to, according to your model, you were supposed to double your money. So this was the way it was supposed to be. But you look at the returns and you didn't double your money. You made, I don't know, less than 10%, for example. Well, was your stock overpriced or underpriced? If you pay too much money for a stock, that means you'll make less return. If you pay less money for your stock, that means it's underpriced and you're making more return. So if in real life you're making a less return than when you're supposed to, then your stock was overpriced. Make sense? Now, I know that this is straightforward, or at least hopefully it's more straightforward when it's positive. What if it's negative? If you're losing money, but you're losing less money than you're supposed to, what does that tell you about the price of the stock? Is it overpriced or underpriced? I expect you to think about that and explain that to me in your project. All right. So, hopefully now you understood how this regression works for us. What you're going to do is you're going to do a separate regression for capital asset pricing model. You're going to do a separate regression for three-factor model. You're going to do a separate regression for the four-factor model, which includes momentum. I expect you to have tabs for each separate regression separately. Now, you can go and have all your data in one sheet, I don't care, but the regression results should be in different tabs. And then what you're going to do is you're going to submit two documents. One Word document, one Excel document. Excel document will have the data and all your regression results. The Word document will have only the actual implications, the model itself, overpricing, underpricing, and your explanations and everything else. I expect a very detailed report. Please do not just write a few sentences per report and expect me to give you full points. That does not mean that I'm looking for number of pages. That's stupid. What I'm looking for is content. Now, I guarantee you, it's impossible to explain all all models in a page and expect me to go over them and you be able to explain what are the betas, what are the factor models, how you approach it, what does it mean, if it's positive, what does it mean, what does it represent, why is the way. You can't possibly do that in a page. I expect you to thoroughly teach me everything that you're doing there. Now, but again, I don't expect you to copy paste the regression results to your Word document. Do not copy paste this stuff in your Word document. This is for the Excel sheet. Now, having said that, one more important note. Whenever I go to your Excel sheet, I need to be able to see that you calculated the returns right here. Okay? I need to be able to see new minus old divided by. Whenever I click on your cells, I need to be able to see the formula that you used. I need to be able to see what you did literally. If you go in and download the returns for a stock from some website, I will not give you any credit for it. I expect you to do it yourself. Okay? All right. Hopefully that was clear enough, at least in the steps wise, how to approach this and calculate it. Again, as I mentioned to you before, there's going to be an email that is attached to this video so that you can read the specific requirements as well. And I will also give you the deadline on the email, and I will also give you the date that you're going to be using, and I will also tell you specifically which stock you're assigned to. All right? Thank you very much for your time, and good luck with the project.